Hey everybody, how are you all doing? Hope you are doing great today. Hope the weather at your place is great. It's sunny outside. Today we are going to discuss about some important topics. For those of you who do not know me, I am Dr. Nandi. I frequently go live on YouTube on my channel and we discuss different kinds of math problems. I have uploaded some of the interesting videos on my channel. If you get a chance, please take a look, and if you like these videos, give me a thumbs up. Other than that, I have also travel videos and other kind of videos in my channel as shorts. Take a look at my shorts. You might find them very entertaining. Okay, without further ado, let me get started. Today's topic is confidence interval of population mean. Okay, to get started on this, first we will start with the standard normal curve. Like in the last lecture, I was talking about standard normal curve or Z curve or Z curve. So we have Z on the horizontal axis. Z is the standard normal variable. Z is the standard normal variable. And Z is given as how far the random variable x is located away from the mean. So this is the deviation of the random variable from the mean divided by standard deviation, where x is the random variable, this is mu, is population mean, and sigma, this is sigma, this is population standard deviation. So basically z-score gives you a number which is how many standard deviation x value is above the mean if the z-score is positive, or below the mean if the z-score is negative. Everything in terms of population standard deviation. How many population standard deviation you are away from the mean. Because you're dividing by sigma, you're standardizing by the standard deviation, you're dividing by the population standard deviation. Okay. Now in the center, so this is a bell-shaped curve like this. In the center, where the relative frequency, remember probability on this vertical axis, and the center where the relative frequency is highest, okay, is the center of this curve. And for standard normal curve, the center is z is equal to 0. So at the center, the z value is 0. Okay. And the standard deviation of this curve is 1. Okay. Now to get into confidence, our confidence is always from the center. Okay. Always from the center. So we talk about 1 minus alpha. This is alpha, level of confidence. And this is an area under the standard normal curve. Standard normal curve on both sides of the center. On both sides of the center. So this area is 1 minus alpha. Okay. So what is alpha? So your level of confidence is 1 minus alpha. Total area under the curve, under the standard normal curve, standard normal curve is 1 because sum of probability is 1. If the area in the center is 1 minus alpha, so area in the center is 1 minus alpha, so area in the two tails is total area minus area in the center. So it is total area is 1 minus area in the center is 1 minus alpha, which is, if I distribute the minus sign, 1 minus 1 plus alpha. So this and this cancel. So area in two tails in alpha. In the two tails is alpha. One thing we have to remember, that the standard normal curve is symmetric. Okay? Because the standard normal curve is symmetric. Normal curve is symmetric. Symmetric means left half equal to the right half. Left half equal to the right half. Area in each tail is equal to total area in the tails divided by 2. In the tails, which is alpha, divided by 2, which is alpha divided by 2. So this portion area is alpha by 2, this portion alpha by 2. Now what is alpha? Alpha is called level of significance. Later on, when we will discuss on hypothesis testing, we will understand what alpha means in this case. However, 1 minus alpha is level of confidence, and it is area in the center around the mean. Okay. So usually alpha is 0.05. Okay. So 1 minus alpha is 1 minus 0.05 is 0.95. So this area in the center usually is 0.95, and area in each tail is alpha by 2 is 0.05 divided by 2 is 0.025. So that means this area is usually 0.025, this area is also 0.025. Now we need to find these unknown values of z. Okay, we usually represent it as minus z alpha by 2. This is the unknown value of z from which we draw a vertical line. On the left of it is area in the tail is 0.025, on the right of it is area in the center is 0.95. Now how to find minus z alpha by 2? It is minus because it's on the left of 0. So we will use TI-84 calculator. TI-84 calculator. We know area in the left tail is 0.025. So I will write what we will do to find this minus z alpha by 2. We will press the second button, then the verse button, then we will select number 3, which is im norm. Im norm is used when the area on the left of the unknown z is known, but the z value is not known. When area is given, we use im norm. When we need to find in area, then we will use second verse 2, which is normal CDF. In this case, area to the left is known, this is unknown, minus z alpha by 2. So we are going to use second verse 3. So let me show you how we are going to do it. So you put the calculator on, clear everything, then second Verse is in the third row. Then number 3 is in now. Area to the left tail is 0.25. Mean is 0, standard deviation is 1. The calculator is already set up for the standard normal curve with mean is 0 and standard deviation is 1. We do not change that. We just put the area in the left tail as 0.025. It should be 0.025. Okay. And then we go down to paste and hit enter twice. And this minus z alpha, so in norm, they will ask for area is equal to 0.025, mean is 0, we are not going to change that, sigma is 1 and we paste. Okay, so minus z alpha by 2 comes out as minus 1.96. So this critical value, this minus z alpha by 2 is called critical value. Okay, and it works out for alpha is equal to 0.025 minus z alpha by 2 is minus 1.96. By symmetry, because left half is equal to right half, positive z alpha by 2 is a critical value on the right. On the right is same value with a positive sign. So this is minus 1.96 and this is positive 1.96. This is z alpha by 2. Same as minus z alpha by 2 without the negative sign. Okay. So we need these critical values if we know to find the confidence interval for the population mean. Why? I will explain that in a minute. Okay. So we will start with the sampling distribution of x bar. Okay. So now we are going to talk about the sampling distribution of x bar. As you know, it is a bell-shaped curve. Okay. It's a bell-shaped curve. And at its center is mu x bar. And its standard deviation is sigma x bar. So we know from central limit theorem, okay, for n greater or equal to 30, mu x bar equal to mu and sigma x bar, the standard deviation of this is the mean of sampling distribution, mu x bar, mean of sampling distribution is equal to the population mean, and standard deviation of sampling distribution is sigma x bar of sampling distribution. Sigma x bar is from central limit theorem is sigma divided by square root of n, where sigma is population standard deviation, and n is sample size. So if you were to convert this into a Z curve, okay, into a Z curve, the center will be 0. Same information on a Z curve. So this is the sampling distribution of x bar. You have x bar values on the horizontal axis. This is a Z curve, Z values on the horizontal axis, center is Z is equal to 0, right? So in this case, Z for the sampling distribution will be Z. Normally is defined as x. Z is the standard normal variable. I defined it already. So Z is equal to x minus mu by sigma. For sampling distribution, Z is equal to x bar, no longer x, okay? X bar, remember x bar is sample mean. X is replaced by x bar. X is the random variable such as people's height, x bar is the sample mean. So x is replaced by x bar in the definition of Z, minus center is also mu, because mu x bar equal to mu. However, in the denominator, sigma x bar, okay, and this is mu x bar actually, which can be simplified as x bar, mu x bar is equal to mu from central limit theorem, and sigma x bar is sigma divided by square root of n. So we have replaced mu x bar by mu from the central limit theorem. This is when we are working with the sampling distribution of x bar. Standard normal variable is defined like that, and sigma x bar is the standard deviation of the sampling distribution, which is standard deviation of the population divided by square root of n. Now we have already introduced the concept of level of significance, okay? So area in two tails is equal to alpha is level of significance. Okay, area in each tail, we also discussed that just now, is alpha by 2. So this is alpha by 2, this is alpha by 2, this area is also alpha by 2. Okay, area in the center is 1 minus alpha. So this is alpha is level of significance, area in each tail, and its area in two tails is alpha, area in each tail is alpha by 2. Okay, usually alpha is 0.05. Now area in the center is 1 minus the area in the two tails is 1 minus alpha, called level of confidence. If alpha is 0.05, then level of confidence is 0.995. 1 minus 0.05 is 0.95. Okay. So these points are located, okay, in a standard normal curve. These points are located, for example, this is minus z alpha by 2 times the standard deviation. The standard normal curve is 1. Okay, so standard mu is 0 and sigma is 1 for standard normal curve, as I have written before. So these points are located. This one is minus z alpha by 2 times 1, which is the standard deviation, and this point is z alpha by 2 times 1. Okay. Why 1? Because 1 is the standard deviation of the standard normal curve. So it is minus z alpha by 2 times 1. This is z alpha by times 1. Why are you including 1? 1 is the standard deviation of the standard normal curve. Okay. In the same idea, with the same idea, these points will be located minus z alpha by 2 times the standard deviation of the sampling curve, which is sigma divided by square root of n. And this point will be z alpha by 2 times sigma by square root of n. Okay. So this area is 1 minus alpha. This is your level of confidence. It is the area around the center. That means the center, as you know, is mu x bar, and you also know mu x bar is equal to mu, population mean. Okay, so that means the sample mean x bar will fall between, the center is in the standard normal curve is z is equal to 0, but in the sampling distribution curve center is mu, because mu x bar is equal to mu. Okay, so x bar will be located on the lower boundary, will be mu minus z alpha by 2 times sigma by square root of n. On the right it will be mu plus z alpha by 2 times sigma by square root of n. This is like the boundaries of the confidence interval for x bar, but actually we want the boundaries for the confidence interval for the population mean. Okay, we want to construct confidence interval for mu, confidence interval for mu. How do you do that? We have this equation. What we will do is we will subtract mu on all three sides. So it is minus mu on this, minus mu on this, and minus mu on this. What happens in that case? They cancel each other out. The mu's cancel each other out except in the center. So we get minus z alpha by 2 times sigma divided by square root of n less than x bar minus mu and less than z alpha by 2 times sigma divided by square root of n. Mu's have cancelled out from the left and from the right. Now we want to solve this equation for, or this inequality for mu. So how will we do that? We will subtract sigma x bar on all sides. So we get minus x bar minus z alpha by 2 times sigma divided by square root of n less than minus mu less than, we are subtracting x bar from both sides, minus x bar plus z alpha by 2 times square root of sigma by n. Now divide by minus 1. When you divide by minus 1, the inequality is flipped direction. Divide by minus 1. When you do that, you finally get the equation for the confidence interval for the mean. And that becomes mu. The lower boundary is x bar minus z alpha by 2 times sigma by square root of n, and the upper boundary is x bar plus z alpha by 2 times sigma over square root of n. So this is the formula for the confidence interval for the population mean. Okay, and confidence interval, it depends on the level of confidence we select. Usually 1 minus alpha is kept at 0.95. That means that if we determine the interval 100 times from 100 sample data, 95 of the population means, okay, will fall in those, or 95 intervals will contain the population mean. The remaining 5 intervals will not mean. So if our level of confidence is 95%, that means if we take 100 samples and construct 100 intervals using this method, 95 out of 100 intervals will contain the actual population mean. So the confidence level 95% is the confidence we have in the method that we are using. So let me summarize what we did. This is the heavy stuff, so let's go through it step by step. So we are going to do confidence interval for population mean. Remember, that is mu. We really do not know mean, but we can collect several samples and get sample means. Okay. So we start with the standard normal curve. Bell-shaped curve, center, z is equal to 0, sigma is equal to 1. Z is the standard normal variable. Z is equal to x minus mu divided by sigma. What is x? Random variable. Anything that we are measuring. Mu is the population mean, sigma is the standard deviation. Basically, z-score is a number which tells you how many standard deviations you are away from the mean. If z is positive, then you are above the mean. If z is negative, you are below the mean. Okay? So, in the center around the mean, we have 1 minus alpha area, which is the level of confidence. Okay? 1 minus alpha is the level of confidence. This is an area under the standard normal curve on both sides of the center. Now we know the total area under the standard normal curve is 1. So area in the two tails is then, total area is 1 minus alpha is the area in the center, which leads to alpha. That means area in the two tails taken together is alpha. But we know the standard normal curve is symmetry. So area in each tail is alpha by 2. So what is alpha? Alpha is a level of significance. Later on, when we will talk about hypothesis testing, we will bring in the concept of the level of significance. At this point, it is important to note that alpha is the area in two tails and area in the center is 1 minus alpha, which is our level of confidence. Area in each tail, because of symmetry, is alpha by 2. Usually alpha is 0.05, so area in each tail is 0.05 divided by 2 is 0.025. Why do we need to know that? Because then we can find these critical values. What are these critical values of z? This separates the area in the tail from the area in the center. So if you go to your TI-84 calculator, use second verse 3 in norm, area in the left tail is 0.025. Do not change the value of mean and sigma. Go down to paste enter and enter. You get the critical value of z on the left when the area in the left tail is 0.025 is minus 1.96. By symmetry, the same value, critical value on the right with a positive sign is 1.96. Now these minus z alpha by 2 of minus 1.96 can be thought of as minus 1.96 times 1. Why do we bring in 1? 1 is the standard deviation of this curve. So as if this is minus z alpha by 2 times sigma, this point. Similarly, this point, this critical value is z alpha by 2 times sigma. Sigma is 1 in this case. Okay. Now we are going to talk about sampling distribution of x bar, which is a bell-shaped curve. Its center is mu x bar on the horizontal axis is standard deviation. is sigma x bar. From central limit theorem, if we have n greater or equal to 30, then mu x bar is equal to the mean of the population. But sigma x bar, the standard deviation of the sampling distribution, is sigma population standard deviation divided by square root of n. What is n? Sample size. Now the standard normal variable is normally defined as x minus mu by sigma. X is the random variable. Now for the sampling distribution, we are not dealing with x anymore. We are dealing with x bar. So z will be defined at x bar minus mu x bar, which is the center of this curve, divided by sigma x bar. Now from central limit theorem, we already discussed mu x bar is equal to mu, so numerator becomes x bar minus mu divided by sigma x bar, which becomes sigma divided by square root of mu, square root of n. Okay, from central limit theorem. What is n? N is the sample size. Okay, so area in the two tails is alpha, level of significance. Area in each tail is alpha by 2. Usually alpha is 0.05. Area in the center is 1 minus alpha. 1 minus alpha is 1 minus 0.05. This is the level of confidence is 0.95. So, just like the standard normal curve, these critical values are actually multiplied with the standard deviation of the sampling distribution curve, which is sigma divided by square root of n. So this is minus z alpha by 2 multiplied by sigma divided by square root of n. Similarly, this point is z alpha by 2 multiplied by the standard deviation of the sampling distribution, which is sigma divided by square root of n. These are the boundaries of the confidence region. So we know from the central limit theorem that the center, which is the sample mean, will fall between these two boundaries, which is because this from the central limit theorem, the mean of the sampling distribution is mu. It is mu minus mu, and you are subtracting to get to this lower boundary. So mu is the center. Okay, let's write it. Mu is the center. Okay, for sampling distribution, mu is the center. So mu minus z alpha by 2 times sigma divided by square root of n is the boundary for the left, and for the right the boundary is mu plus z alpha by 2 times sigma by square root of n. But this gives us a boundaries of the sample mean. We are not interested in sample mean. We already know the sample mean. Our goal is to find the boundaries of the confidence interval for mu. So how do we do that? We do some algebra. We subtract mu on all three of them, and then it becomes minus z alpha by 2 sigma square root of n less than x bar minus mu less than z alpha by 2 times sigma by square root of n, because mu drops out because we are subtracting mu all through. Now what are we going to do? We have to remove the x bar from the center. How do we do that? We subtract x bar on all three of them. So this is what it becomes. Now we want to find the confidence interval for the population mean. Minus mu will not do the job. We have to divide by minus 1 to get rid of the minus sign. Now algebraic inequality, when you divide by minus 1, the direction of the inequality changes. Or in other words, by dividing by minus 1, mu will come in the center. On the left will be x bar minus z alpha by 2 times sigma by square root of n. On the right boundary will be x bar. This is x bar. This is also x bar plus z alpha by 2. This is the formula for the confidence interval. Formula for the confidence interval. Interval of mu. X bar minus z alpha by 2 times sigma divided by square root of n lower boundary, upper boundary is x bar plus z alpha by 2 times sigma by square root of n. The term z alpha by 2 times sigma divided by square root of n is called E, where E is margin of error. Margin of error. Some books also gives margin of error as M. Okay. So basically this formula becomes then x bar minus E less than mu less than x bar plus E, where E is the margin of error and E is given as z alpha by 2 times the standard deviation of the sampling distribution, and in other words sigma divided by square root of n. I think I will stop here. I know I have thrown a lot of stuff at you. If you have any question, please do not hesitate to write me a short question. I'll answer you right away. Okay. And if you like this video, please give me a thumbs up. If you like this video, share with your friends. You and your friends. Please subscribe to my channel by hitting the red subscribe button. And if you have any question, shoot me a question. I'll respond to you right away. And please do not forget to watch me tomorrow when I'll bring in another new video, introduce another new concept. Thanks for taking the time to watch my video. I really appreciate that, and please give me a thumbs up if you like this video. And I hope to see you tomorrow. Thanks for taking the time today to watch this video. Hope you have a great rest of your day. Take care. Have a nice day, and I'll see you tomorrow. Bye.